Hey everybody, back with another Polars tutorial. Hope you're all doing real well. Today I'll be doing an introduction. This is the first part of a multi-part series. I don't really know how many videos it's going to be, but the first part of a series I'll do on date and date time columns. It's pretty detailed and there's kind of a lot to go over, so I'll just keep it very introductory this time around. The input dataset I'll be using for this is just a dataset I downloaded from the internet. I don't know if this is real data or data that just some person made up, but it's historical data on earthquakes. So we have a year where the earthquake took place, the month, the day, the hour, and the minute, and the second of it, as well as the magnitude and the country in which it occurred. I say I'm not sure if it's real or not because there's like a year 50 in here. So I'm not sure if people are really that good at record keeping, but we're going to use it because it's kind of a fun data set to use. So in this video, I'll talk about how to create date and time columns and what component information you'll need, and just some of the considerations you're going to need to make. You'll notice that a lot of our date information is missing in here, and that has certain ramifications. We'll talk about what date time columns contain, and how to get component information from a date time variable. So in other words, let's say we use all this temporal data we have in here to create a date time column. What happens when we want to get that component information out? So what if we want to get out the year, the day, the month, that kind of thing? So we'll go over that. And then one thing that kind of puts people off, including myself, with date time variables and a lot of statistical packages, is it's not clear what you can and can't do with them, and it's not clear like how to do logical tests with them. So what if you want to test whether a date is greater than January, I don't know, 10th, 2020? How do you do that in a logical test? So I'll show you how to do that with Polars. It's actually not that bad. I think they did a pretty good job setting it up. So we'll just get right into it here. So first we'll go over how to create a date and a date time column. So Polars has two different date columns. At least I think it only has two. There could be others, these are just the two I use the most. So there's date, and you create a date with three component pieces of information, the year, the month, and the day. At least I think that's what you use. And so the date column, so basically what you do is you type in pl.date, and then there's three arguments. There's an argument for year, and so we have a column for year in our data set, so we enter that, and then a comma, and so then you have a column for month. And then you'll see what I'm doing here. I'm putting fill null 1. If you have missing data on any of your component pieces, the resulting date variable you create will be null as well. So this is a consideration you need to make. So if you have missing date information, sometimes it might make sense to fill it in. Sometimes it might make more sense to have the resulting date column be missing. That's just something you'll need to kind of think about. So here we're just assuming that if month is missing, then the event, in this case the earthquake, happened in January, and if day is missing, it happened on the 1st of whatever month that may happen to be. And we'll call this date. And again, all this is going in a with column statement since we're creating a new column. So we're creating this date column here. Okay, and so then the second type of column is a date time column, and this is far more precise. And this is if you have considerations like the hour, the minute, and the second of the day are really important to you. And so there's how many is this? Gosh, six arguments for this function. And so you do pl.datetime, so not date, date time. So this is a separate data type. They're both temporal variables, but one is a date and then one is date time. And date time distinguishes itself from date because it has information about the time as well as the day. So hour, minute, and second of the day. So there's 6 arguments: year, month, day as before, but also hour, minute, and second. And again, we're filling these with 0. So with hour, we're assuming that if hour is missing, we're just going to fill it with a 0. So in other words, the first hour out of the day, so midnight basically. If minute's missing, it's going to be 0. Same with second. So just top of the hour, and we'll call this date time. And then we'll drop the component information just so we can focus on how the variables look. and see what they contain. Okay, so here's our data now. So we see we have a date column and a date time column. And so here's our date column, and we see that it has the year, the month, and the day. So it's a very intuitive way of expressing the date. You don't have to format it. You just kind of print it out, and it's pre-formatted for you in a way that's very intuitive to look at. And we see that the date time column has the exact same information as the date column, except it has this extra time information, so the hour, the minute, and the second. Okay, so that's really all there is to creating a date and time columns. It's pretty easy to do, and and the layout of these variables, just in your data frame, are very intuitive to look at. So now that we have this information in our date time column, what happens when we want to get component pieces of this variable out? So what if we want to create a column for year, of just the year, by extracting year from this date time column, or month, or day, or second, or whatever it might be? It's actually very easy to do that in Polars too. So for this example, we'll use the date time column, and so we're going to recreate year, month, day, hour, minute, second, and then we'll also get week and century from this, which is kind of a curious addition into this package. I think it's kind of cool, but I've never seen that before. Kind of interesting. So to do this, it's very easy. So you point to the column you want to extract the information from, and so here we're going to extract it from this date time column we created. So in other words, this guy right here with the date information and the time information as well. And then you do .dt, since these are date time methods that we're using, and then use .year, .month, .day, .hour, minute, week of the year, and then century. And so week of the year runs from 1 to 52, I believe, if I'm remembering that there are 52 weeks in a year correctly. Hopefully I'm right on that. And so what this is going to do is it's going to extract the year from our date time column. It's going to extract the month from our date time column, and so on and so forth. So as we can see, it's actually quite a simple matter to get these component information pieces out. Okay, so there's our component information again. You see we were able to get all of this all of this time data out of our date time column, just using those very simple but very powerful methods. So we have the year, the month, the day, the hour, the minute, the week of the year, and the century in which this took place. The first century. Did this really take place in the first century? That is so hard to believe. See, look, they didn't even know. Well, I guess they wouldn't know the magnitude. They didn't have magnitude back then. They just kind of knew if it happened. Okay, moving on, though. And so again, one thing that kind of puts people off about date time variables in any statistical package is how to work with them and how to do logical tests with them. So in other words, what happens if we want to test that a given earthquake happened after a recent date? So in other words, what happens if we want to know like how recent these were, if these happened before or after 2001? So it's actually really easy to do that in Polars. So what we're going to do is we're going to create a flag for recent earthquakes. If the quake happened after July 10th, 2000, then we'll create a flag and we'll have the value for that be recent. Otherwise, we'll set the flag to old. And so this is actually a pretty easy thing to do here as well. I've read over a lot of documentation for Polars date time columns and methods, and some of them are a real challenge, but then some of them are actually kind of easy. This is one of those things that's actually pretty easy. So the way in which we're going to create this new variable, we're going to call this variable recent. And so we're going to do PL when because we're doing a logical test. So when the date, and so we're using this date column with 3 pieces of component information, which is an important consideration. and we want to test if this date is greater than another date. And so the way we create the test value is, again, we just use PL date. So again, very easy, and we write in the year, the month, and the day. So if this earthquake took place after July 10th of 2000, then we're going to give this variable the value of recent. Otherwise, we're going to give this variable the value of old. And so we'll just go ahead and run that and look at the results. Let's look at, I don't know, like 1,000 records, just for fun. Okay, so there's our recent column. I'll zoom in a little bit just so we can see. And we can see it has values of old until it gets to 1999. So yes, this earthquake happened after July 10th of 2000. So this is recent. Then we get to Albania. Just zoom out a bit here. We get to Albania. Then we have a few recents there too. Okay, guys, so that's a brief introduction to date and date time columns and polars. In a subsequent video, be sure to check out. I'll talk about how to actually get some statistics for duration with these variables. In other words, how much time elapses between one earthquake and the next. So that's one of those things that is a bit more of a challenge, but is something we can do using these date columns. So thanks so much for watching, and have a good day.